0 and 90 degrees, angle formed by the terminal side of theta and the x-axis. So if we look at 30 degrees, the reference angle of 30 degrees is actually the quickest way to get to the x-axis. That's my advice to you. It's the quickest way to the x-axis, which is still 30 degrees. So most of the time I won't ask you for that reference angle, but if I did, you'd go theta prime equals 30 degrees. Mr. Pavian, I didn't have to do anything. It's already between 0 and 90. It's already an acute angle. If I have 150, though, the quickest way to the x-axis is that direction there. Well, this is 180 degrees, so what do I need to add to 150 to get to 180? 30. Oh, what a surprise, right? So I would then say, okay, theta prime equals 30 degrees again. 210. Now, we don't want to go all the way to here to get to 180. The quickest way is going up in that direction. I'm going to draw my arrow in the correct, because that's a positive. It looks like it's minus 30, but we need the positive version of minus 30, which would just be 30 degrees. It's interesting they said minus 30. Minus 30 would actually work in this example, but it's supposed to be a positive 30. So our theta prime would equal 30 degrees. And our final one, it's definitely not quickest to get to this direction, so we're going to go full 360. That's how we get the quickest to the x-axis. So 330 plus what equals 360? 30 degrees again. Theta prime equals 30 degrees. All of them are 30 degrees, which means if you know the sine of 30 degrees, you know all four of those. Because that reference angle is the exact same value for all of them. Your job is just to understand when it's positive or negative in quadrant 3 and quadrant 4. That's the power of reference angles, that you just need to know quadrant 1, and you know everything else. So if I asked you to calculate the sine of 30, 150, 210, and 330, all you'd have to know is the sine of 30 degrees. So you could go, okay, the sine of 30 degrees is 1/2. And we know it's going to be a positive 1/2 because of that all students take calculus. This is all are positive. Now we know all the rest of them are also 30 degrees. You just have to know the quadrant to decide if it's positive or negative. So if I give you sine of 150, I guess I should write that down. Sine of 30 equals 1/2. If I asked you for the sine of 150, we should already know it's 1/2. Whether it's positive or negative depends on the quadrant. We have all students take calculus, so sine is positive. It means sine is positive. All students' sine is positive. So we're going to have a positive 1/2. When I get to sine of 150 equals a positive 1/2. When I get to 210, we are suddenly in quadrant 3. Tangent is positive, so everything else is negative. That's that all students take. So that means my sine value should be negative. I guess I could put those in parentheses. So we should have a negative 1/2. And while I'm on the unit circle, I'm going to finish the last one. The last one's in quadrant 4. What's the only thing that's positive in quadrant 4? Cosine, because it's all students take calculus, or precalculus, if you can say it that way. As long as P isn't positive. I don't know. All right, so our sine would be negative, so we'd have a negative 1/2. So we'd have a 1/2, 1/2. Sine of 210 would be a negative 1/2. Sine of 330 would be a negative 1/2. That's the power of coterminal angles. And surprisingly enough, they're much easier with radians. Degrees are actually harder to use them than radians. Because I'm going to tell you right now, pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3 all have the same reference angle. What do they all have in common? The denominator and the pi. So they all have something to do with pi over 3. So if I ask for the cosine of pi over 3, we'd go to pi over 3 and we say, oh, that equals 1/2. Since they're all pi over 3s, they're all 1/2, you just have to know what quadrant it's in to put a positive or negative on it. So if I was just, okay, this is 1/2, How do I know 2 pi over 3 is in quadrant 2 as one of Mr. Pabian's tricks, looking at the numerator and denominator?
It's in the first one because it's just one.
It's just one.
What about the 2 over 3? What quadrant is that in?
Two.
1 less, so it's quadrant 2. 1 more, it's in quadrant
3.
something else, it's in quadrant 4. So now you just have to know whether it's positive or negative in those particular cases. In quadrant 2, cosine positive or negative?
Negative.
Wait, 2 negative.
Ooh.
Quadrant 2 negative.
Okay, we're in quadrant 2, so we have our all students. What's positive? What was that? Cosine is negative. So we'd be in quadrant 2 and we'd be negative. Yeah.
Can I borrow Mr. Hammond's and Mr. Moses really quick?
Sure.
Crazy news. Oh boy, what they do now?
You're next, don't worry.
All right, so quadrant 2, negative. Quadrant 3. Let's refocus. Quadrant 3 is cosine negative or positive? Negative, so we have negative. Quadrant 4, positive. So if this is 1/2, negative 1/2, negative 1/2, positive 1/2. And if we follow this on our unit circle, 2 pi over 3, cosine is negative 1/2. 4 pi over 3, cosine is negative 1/2. 5 pi over 3, cosine is a positive 1/2. So you just had to realize that we had a coterminal angle, figure out that cosine of pi over 3 equals 1/2, and you have everything else as long as you know it's positive or negative, which is easier than having to draw the whole unit circle. These are going to be very quick ways for us to get quick answers instead of having to go, oh, Mr. Freeman, I got to find my unit circle real quick. Yeah.
How do the letters correlate? I don't get how that acronym correlates to the signs.
Oh, yeah. So all, the A stands for, well, all stands for everything's positive. So don't worry about it. All students, S stands for sine is positive, everything else is negative. So that means cosine is negative, tangent is negative. All students take, that's tangent, nope, I didn't put take, I said tangent. Take stands for tangent is positive, everything else is negative, so sine and cosine are both negative. And finally, calculus or precalculus, cosine is positive, everything else is negative. So it tells you what's positive. We have all these fancy formulas for if it's in degrees. I don't really use these fancy formulas. All I'm looking for is it closer to 180 or 360? That's going to be the question I'm going to ask you. So this says if you're in quadrant 1, it's yourself. If you're in quadrant 2, you're going to do 180 minus theta. If you're in quadrant 3, you're going to do theta or your angle minus 180. And if you're in quadrant 4, you're going to do 360 minus theta. Yeah. Yeah. So I'm going to ask you a different question than what quadrant it's in. I'm just going to ask you, is 205 closer to 180 or 360? It's closer to 180. How far away is it from 180? Knowing that you have to give me a positive answer. It's going to be 25 away. So your reference angle is 25. So if it's in degrees, is it closer to 180 or 360, and how far away is it? That's the only questions you have to ask. Since it's 205, it's closer. We're going to have 25. If we did the formula, it would be theta prime equals 205 minus 180, which equals 25 degrees. But I don't find that super rememberable. Yes?
How would that apply to the first quadrant?
It would. So if you found the cosine of 25, it would be the exact same thing as the cosine of 205, except it would be negative in this. Or I'm sorry, it would be in quadrant 3, so it would still be negative. But we don't know that value, so it's just an arbitrary example. Now for radians, look at this arbitrary example. 109 pi over 4. I can tell you right now that if I needed to find the cosine of 109 pi over 4, it is square root of 2 over 2. I just don't know if it's positive or negative. Because the reference angle of this, you just get rid of the 109 and you take the pi over the denominator, and that is your reference angle. What was that?
All the time?
It's all the time with the ones we're using. So with the angles we're using, it's as easy as that. So I might not know whether it's positive or negative because 109 pi, that seems like lots of revolutions. But at least if I'm on a test, I could tell you that it is for sure going to be pi over 4. So if it's cosine, it's square root of 2 over 2. If it's sine, it's pi square root of 2 over 2 also. Which is pretty cool because it's 109 pi over 4. You think you'd have to subtract 2 pi over and over and over until you get there. You don't. You can go ahead and already know that information. All right, we're going to skip some stuff. We're going to do these two, and then we're going to skip down. Okay, sketch the reference angle of theta prime. Well, negative 7 pi over 4. So my first thing is, what should the reference angle be? It should be pi over 4. It's as easy as that. If I asked for the reference angle, it would be pi over 4. Well, how would it look on here? Well, negative 7 pi over 4 goes in the negative direction, and it goes to about here. It goes 2 pi over 4 backwards, right? So the reference angle would be here. So if it says sketch the reference angle, oh, that's just this guy pushing back on it. That's all it means by draw your reference angles. Draw your angle, and then draw your arrow going, yeah.
Is that because on the unit circle, that's where pi over 4 is?
Yeah.
Is that why?
Well, yeah, and because they gave us negative 7 pi over 4 to start off with. I'm not a huge fan of degrees. I like radians more. 690, it definitely does one full revolution. How do I get rid of that revolution so I actually know? I subtract 360. So we'd go, okay, let's subtract 360 from this, get something called a coterminal angle. Our coterminal angle is going to be 330 degrees. That is coterminal. We do need to realize that that means this goes all the way around and then goes all the way to about here. Here's my question for you if I ask for your reference angle. Is that closer to 180 or 360? 360. How far away is it from 360? 30 degrees, so your reference angle is 30 degrees. And that can help you, A, know the value, and B, how to draw it. That's 30 degrees. So I basically knew by the reference angle to stop about here because I have 30 degrees left over. So we're going to have theta prime equals 30 degrees. I'm going to skip the next two, and I'm going to go straight to finding the sine and cosine using these values. So I'm skipping to these. Find the sine and cosine using a reference angle. 120. Is that closer to 180 or 360? 180. How far away is it from 180? 60 degrees. So we need to know two things. So I know theta prime equals 60 degrees. I also need to know what quadrant we're in. Not what quadrant 60 degrees in, because that's always our first quadrant. I need to know what the original angle, what quadrant. We're in quadrant 2, right? So as soon as I know I'm in quadrant 2, so I could even point to that and say, hey, I'm in quadrant 2. So I'm in quadrant 2. Before we continue on, just remember these are reference angles. So this brings us to the first quadrant, so everything's positive. We have to ask, should it be positive or negative when we get done? Yeah.
How do you know it was supposed to be 180?
That was from here. When we're finding our reference angles, we're just looking, is it closer to 180s or closer to 360?
Okay.
So we're getting our quickest way to the x-axis. Okay.
You asked if it was supposed to be positive or negative?
Yeah, because when we're doing these, we're looking at sine and cosine, right?
It's sine, it would be positive.
And if it's cosine, it should be,
It would be negative, it's on that.
it's on that quadrant 2. So that would be our all students. So our sine would be positive, cosine would be negative. Take, everything's negative. But we're in quadrant 2, so I can just stay there. So we could do something like, oh, whatever I get, sine needs to be positive and cosine needs to be negative. Because the problem with reference angles are, they're always going to make it positive. They're always going to make it positive, but we have to think about whether they're going to be positive or negative. So now they're asking for the sine and the cosine using the reference angle. So we're going to say something like, well, you know what? The cosine of 120 degrees. I'm going to leave a little blank here, but I'm going to put it's the same as the cosine of 60 degrees. I put a little blank there because these aren't guaranteed to be exactly equal. The value will be the same, like that fraction is going to be the same, but the positive or negative might not be the same. So we have to decide what we're going to put there. Either we're going to put a positive there and say, hey, it's going to stay positive, or we're going to put a negative there and say it's going to switch to be a negative while using this. Should our end answer be positive or negative? Negative, question mark. Lalo, you're questioning it? What makes you think it's going to be negative?
Because it's cosine negative.
Yeah. So we don't have to ask a question. We could be like, it has to be negative. I knew from the start it had to be negative. So I'm going to make sure, I'm going to put this in red. I'm going to say that has to be negative. Now the only thing we need to know is quadrant 1. What's the cosine of 60 degrees? Remember, 60 degrees is our 1, 2, 3 tick mark. What is the cosine of 30? Who thinks they know what the cosine of 30 or 60 degrees is? What do you got? You're going with 1 over 2 or 1/2, so we're going to make this a negative 1/2. Now we'll do the same thing for sine. We'll say sine of 120. It's not always exactly the same as the reference angle. In front of this one, do I want to put a positive or do I want to put a negative in front of that one? I want to put a positive because what quadrant are we in? 2. We're in quadrant 2, so sine must be positive. So I actually put a positive out there. It's redundant, but it helps me remind myself that I'm the one that decided it should be positive or negative. It makes me think that way. And if cosine was 1/2, what goes with 1/2? Square root of 3 over 2, and that would be a positive square root of 3 over 2. 7, pi over 6. First of all, what quadrant am I in, and how do you know it by using kind of the numerator and denominator? We're saying 3. Who thinks they can explain? Yeah, Lewis. It's one more than denominator, so I know I'm in quadrant 3. So if I was to ask to draw this, we'd end there. Can someone raise their hand and tell me what is the reference angle? For these should be easier. Connor? It's going to be pi over 6. So our reference angle is pi over 6. Ooh, that's a Q. Reference angle equals pi over 6. This would be pi over 6 then. We are now in quadrant 3. Is sine positive or negative?
Negative.
Is cosine positive or negative?
Negative.
What would be the only thing that's positive?
Tangent.
Tangent for right now, because we didn't really cover it, so we're going to go with nothing. Sine and cosine are both negative. So both our answers need to be negative. If it's sine, we put a negative. If it's cosine, we put a negative. So reference angle wise, we can go, the sine of 7 pi over 6. I'm actually going to throw that down a little bit. I don't know why I'm cramming it up there. Is it going to be the exact same as sine of pi over 6?
No. Yeah. Wait. Yeah.
Is it going to be exactly the same? Listen to the question. You should hear it because it's one of those I'm rephrasing as, is it exactly the same?
No.
Because I'm going to say sine of pi over 6. Do we agree sine of pi over 6 is 1/2? It's got to be. Why is it negative? Because we're in quadrant 3, so we should have put a negative here, and we should have put a negative there. For cosine of 7 pi over 6, we're going to have equal to the cosine of pi over 6, but once again, we're in quadrant 3, so we're going to put a negative. And we're going to have a negative square root of 3 over 2. So I'm going to remind you, this stuff is really for you to speed up so you can use the unit circle and just know quadrant 1. On the test, I can ask you what your reference angles are. And for the homework, I will ask you what the reference angles are. But I highly suggest for the homework tonight, try to use reference angles. The quicker you get these, the easier it becomes. Yeah?
The reference angles are always positive.
The reference angles are always positive. It's always an acute positive angle. So it's something between 0 and 90. I mean, if it was 90, you probably wouldn't be using one, but. Questions on any of that? All right, we really don't have a ton of time for the cheat sheets, but my advice is write your all students take calculus on one of these. And we can fill out the other one tomorrow. All you really need to know is all students take precalculus. We just have to emphasize the calculus if we're using the pre on there. Yeah.
Question on so how come?
Yeah. Shh, guys.
How come the like I'm so confused how you know what quadrant it's in.
So we have
Is
to
it the whole
we
thing or just the pi over 6?
we have to look at the original angle. The original angle basically tells you whether it's positive or negative. So we're going to go, okay, 7 pi over 6, it's one more, so it's quadrant 3. Once we know it's positive or negative, I'm kind of done with this, and I'm focusing on the reference angle.
What do you mean by you know? Like, is it 7 over 6? That's
Mhm.
Okay.
Yep, so you might memorize where it is, but we talked about, like, on those special ones, if our numerator is 1 bigger, you're in quadrant 3. If it's 1 smaller, you're in quadrant 2.
So how come the negative 7 pi over 4 wasn't
We were going the opposite direction. So positive goes this way, negative has to go this way. You're welcome. Have a wonderful day.
oh, so it basically flips upside down.
Yes, the rest is your
So
homework.
it basically flips
We're
upside
basically
down.
flipping. So if this is in quadrant 4 and I go the opposite direction, I'm back in quadrant 1. Does that make sense?
Yes, sir.